Solve this linked list problem, and we're here to find out if there is a cycle in this linked list. And to do that, we will need to take an example first, and we're going to just check this example. So we have this small linked list 3 2 0, and instead of 0, if it was actually pointing to a null, it would be the next pointer would be a null, because it would be a valid linked list without any cycle in it. But if it was constructed like this, that instead of null, this next pointer for 0, actually not 0, sorry, let's do it over. The next pointer is going to point to 2. There is a cycle, obviously. And how do you detect that? So there is a one way of solving this, using a hash map. If a node can actually be in a hash table, if you have seen it or not, and it can be a set as well. If you use a set, in that case, you can just iterate through each node at a time, because in a linked list you're only given the pointer to this node. So this is the first node's pointer is given, and this is probably going to be called a head, head of the linked list. And for each one, the next pointer points to the next one. And for this one, this is the next pointer for this node. And if you use a set, you can actually keep in memory, okay, I have seen 3, then you guys go to 2, we just take the next node 2, and after 0, we have to see what is the next one, and you have seen it or not. So when you just take this node 3, we just say, wait, we have now added 3, the next node is 2, and we haven't seen it in the hash set, so we added here as well. Now we come to the second node 2, and we come to node 2. We said, hey, the next node is 0, and we haven't seen that, so let's add that 2 as well. And now we come to 0. Now 0 node says, hey, the next pointer shows 2, and 2 is already in the hash set, but in this case you're going to require a space, an extra space. A space complexity will be order of n, where n is the length of the array, and the time complexity will be order of n as well, because you have to go through each of the nodes. But you can actually just save the space, and there's a better way of doing it, and that is going to reduce the runtime to order of 1 only, and that is by considering 2 pointers. One is called fast and the other is called slow. So let's erase this and create a new example, and let's say 3 2 0 minus 4 is just the example that I've given, and 4 points to 2. And in this case, you create 2 pointers. One is called slow and one is called fast, and I'm just pointing at S and F. And each time, in each iteration, when you give an iteration, slow goes to the next one and fast goes to next one. So fast is moving 2 steps at a time, and that way, after one iteration, slow is here and fast is here, right? And we can forget about its previous positions, and we know that fast moves 2 steps, so it will be fast is moving actually here now, and slow is going to be moving to this position. So now this is slow and fast, and after another iteration, slow is going to move to here. So this is the final position of slow, and fast is going to move from 2 to 0 to 4. So at this point you can say, hey, this is the same node, and we can actually just say there's a cycle. But what if there is no cycle? And you have to consider 2 cases for that. 3 2 0 minus 4, and in this case this is pointing to a null pointer, so there is no cycle at all. And you have to also consider this is an even length, and you can see the fast pointer jumps 2 steps at a time. But if there are actually odd number of nodes, so in this one there are only 3 nodes, and this one there are 4 nodes. And what happens when you take the fast 1 2 and then fast goes 1 2, and at this point you can actually run the loop until the fast next dot next is not null, right? But in this case you have a fast pointer here, fast goes here, and you have to just check the null next is not null. So you have to just consider 2 cases, and it will be fairly straightforward to define, and eventually you want to just return true or false. This is very simple. So we defined two list node. One is fast, and this is pointing to head, and there is slow, which is also pointing to head. And the condition is the fast dot next cannot be null, and this checks the cases where there's odd number of nodes available, and if there's an even, so we have to just check the next is also not null, and if there is no cycle it should return false by default. But in each step, slow is going to move one to its next 1 step at a time, but fast is going to move twice at this speed. Fast dot fast, and we have to check if slow is just pointing to the same node as fast, and in this case we have to return true, and that is going to produce the answer. And let's submit that. Okay, I made a mistake somewhere. Probably have missed something. Okay, so I actually missed, and that actually caught us off guard when submitting. So in case this head is actually null, so in that case we have to just return false, and at the time it will capture that corner case. Let's submit that, and yep, it passed with order of n runtime and order of 1 space complexity. So this is going to be time is space order of n, and a space is order of 1. Thank you for watching.